Hello fourth year. This video is going to have a look at what's called indirect, sometimes called inverse proportion. So if you think about direct proportion, which is the work that we've just done, that's where when one quantity goes up, so does the other. So if you think about, I think the example I used was wages. If you're paid by the hour, the more hours you work, the more money you earn. Okay, if you work for an hour and you get paid £10, if you work for 2 hours, you'll get paid 20. If you work for 3 hours, you'll get paid 30, and so on. So that's direct proportion, where one thing goes up, so does the other. The opposite is, of course, true. Okay, so sometimes you have an example where as one quantity goes up, the other quantity goes down the way. So if you think about, I mean, the most obvious example would be pick a manual job. So talk about building a brick wall, possibly. If it takes one person 3 hours to build that brick wall, we can probably assume that it would take two people an hour and a half. Okay, it would take half the time because we've added an extra person. If we put in a third person, potentially it would then only take an hour. So the more people who are involved in a job, the less time it takes. Okay, now you can argue that there are cases where that only works up to a point because sometimes there's too many people and then you don't get the same benefit, and you'd be right. Okay, that does happen in certain circumstances. But for the purposes of the questions we're going to look at, we're going to make assumptions that as one quantity goes up, the other goes down. Okay, so there's a couple of examples on this page for you here. I am going to work through these. We're going to stick with the cross way of laying things out, okay? But you're going to see a little bit of a difference. Where in the last examples we've been consistent, where we've multiplied on one side, we've done the same on the other as we've moved down the table, or where we've divided, we've done the same. What you will see in inverse proportion is the opposite effect. So as we go in one direction, on one side you might multiply, on the other you'll divide, and vice versa. That's the difference with inverse proportion. So let me just pop in my cross here and here. Give myself plenty of room this time. So it says it takes 5 men 12 hours to clean a fleet of buses. So we've got the number of men and we've got the time it takes in hours. Okay, fine. So that's those two important bits of the question. I've got men, I've got hours, and I've got 5 and I've got 12. So I can pop that in there. So 5 men, 12 hours. Okay, fine. As we've done with direct proportion, if we can find out how long it would take one person to clean a fleet of buses, then we could easily work out how long it would take any number of people, because once we know how long it takes one person, we can just apply that ratio. So to go from 5 to 1, I hope you agree, we divide by 5. Now think logically. If we reduce the number of people cleaning those buses, then obviously it's going to take longer. Well, that means we've got to multiply, okay? Because if we divide them, we've reduced the time, and that doesn't make sense. The less people, the more time it's going to take. So what we're saying here is actually it would take one person 60 hours to clean a fleet of buses. Don't fancy that job myself. Next question is, if 4 men, I hate that it says men, if 4 people were asked to do the job, how long would it take? So let's multiply that by 4. 1 times 4 is 4. Okay, if we multiply by 4 on this side, again, think logically. We're increasing the number of people, so we're going to reduce the time. Reduction implies division is happening. 60 divided by 4, I happen to know, is 15. Okay, so what we're saying is 4 people would take 15 hours. Okay, job done. Alright, now notice the differences. Divide, multiply. Yeah, and then over here, multiply, divide. So we're doing the opposite thing with indirect proportion rather than the same thing. Alright, next example. So we've got 5 mountaineers and we've got food, and it's going to last 12 days. Alright, so let's pop the cross in here. I'm trying to set a good example using a ruler here, or the iPad equivalent of a ruler. Oops. There we go, right. So what do we have? We've got the word mountaineers, that's a bit of a pain. Mountain. I would forgive you with this question if you just wrote people. And we'll call this days of food, because that's what it is. So 5 mountaineers, 12 days worth of food. Again, same strategy. We want to work out, well, if we had one mountaineer, if we had one mountaineer, how long would that food last one person? So we divide by 5. Divide by 5 over here as well. That's going to give me 12 over 5. Why is that wrong? Because I've divided, haven't I? Which is exactly what I've told you not to do. So let's just rub that out. Inverse proportion, okay? So just be careful of that trap. You've just seen me fall into it myself. Think before you start writing things down. If we've reduced it from 5 mountaineers to 1, obviously that food's going to last 5 times longer. So 5 times 12 is going to give me 60. These numbers are almost exactly the same. Slight differences. That's just pure coincidence, okay? Your numbers aren't always going to be 5, 12 and 60. I can promise you that. Next bit of the question. Another 7 climbers join the group, but they don't bring any food. So no more food, but an extra 7 climbers. 7 plus 5, that's 12. So to go from 1 to 12, we've multiplied by 12. So to go from 60, we're going to divide by 12. 60 divided by 12 is 5. So what we're saying here is the food will now last 5 days. Okay. Again, have a look. Division, multiplication. Multiplication, division. Alright. This table method of laying things out is really just designed to help you. The important thing with these questions, guys, is to think about it. Okay? Don't turn your brain off and look for a process to follow. Think about it carefully. Okay? If you increase the number of things happening, increase on one side, decrease on the other. Decrease on one side, increase on the other. So you can think about it logically, and it should help you to get to the final answers. Okay? Something that is really important for you to know, and I think I've mentioned this before, but just so you're really, really clear, these examples that I do in the video are available in your class notebook. So if you go into your class notebook, which is available through Teams, I think you click on more and it should offer you the chance to go into your class notebook. I've shown you this in class as well. And you go into ratio, so into your content library, and then into ratio, you can see all of the things that I've produced videos for. You can see the examples are still there for you, so you can go in and you can have a look at the examples in the format in the book.